I'm going to start working through the test review problems for the midterm exam. I do have the answers with me, so hopefully after I work each problem, I'll check the answer. There's no guarantee that I'm not going to make a mistake, but hopefully if I check the answer and make it, then I can go back and correct it. So we'll just start working through these. Hopefully you can see these. These should look just like the problems you're going to be solving. I'm going to go through these pretty quickly. I'm not really teaching how to solve these problems, although I will talk through the things you think about as you work in these problems. So this first problem is a multiple choice question. It wants to draw the 45-degree angle. So hopefully we all know by now that the x-axis is 0 degrees. Straight up would be 90 degrees, so which one of these is 45? It would be halfway in between. It looks like it's B. So there are a lot of problems on this review, but a lot of them may be like this, where it only takes a matter of seconds to complete it. Number 2, same kind of problem, 315 degrees. For some of these, you can refer to your unit circle. For instance, 315 degrees is actually a special angle. So on the exam, just to have note, you will be allowed to use your unit circle, and you will also have this formula sheet, front and back. But I know that 315 degrees is down here in the 4th quadrant, so the answer is going to be A. All right, 510 degrees, a little trickier because we know all the way around the circle is 360 degrees, and we're at 510. So really what we have to find is what we call a coterminal angle. So what we do is we want to find an angle that starts and stops as the same as 510 degrees, but is within the unit circle. It needs to be between 0 and 360. In other words, 510 degrees means you go all the way around, and that's 360, but then you have to keep going until you get to 510. Well, the question is, how far do you have to go around again? So you take 510, subtract 360, because 360 is one time around the circle. So this is a simple. So it looks like to get to 510, you go all the way around 360, and you need to go 150 degrees more. Now we know 180 degrees is straight across, so 150 must be here. But we have to pick the indication where you go all the way around, and then you stop over here. So hopefully you can see that it's going to be B. And the last one on this first page. So now the angle's in radians, 5 pi over 6. So now you have to recall that 0's here, pi is over here. What I typically do is, if I have a fraction here, I can rewrite pi as 6 pi over 6. And actually 5 pi over 6 is one of the special angles, and we know it's over here in the 2nd quadrant. And this is 5 pi over 6. So, problem number 5. Here's another one, negative 7 pi over 4. Okay, here's a new twist. Now we have a negative angle. Positive angles start at the x-axis, and you go counterclockwise. Negative angles start at the x-axis, but you go clockwise. Now what I typically do with a negative angle, because if I look at my unit circle, all the angles are positive, what I will typically do is I will say, when I go in the positive direction, how far do I have to go to get to 7 pi over 4? 7 pi over 4 is right here. I start here, I go 3/4 of the way around, and then I go another half a quadrant. So if I imagine doing that, but just going the same distance, but in the opposite direction. So I go 3/4 of the way around, and then I go another half a quadrant, and end up right here in the first quadrant. So if I look, these two look pretty similar, but I actually have to end up right in the middle of the first quadrant. So it's going to be this right here. All right, next question. All right, now, converting. So angles can be expressed in degrees and radians, and we have to know how to convert back and forth. So this is where you use the idea of the unit fraction. So if I'm starting with 435 degrees and I want to get to radians, I start with degrees. Degrees go in the bottom, radians go in the top of my fraction. And I say, what's the relationship between radians and degrees? I know there are 180 degrees in pi radians. Now you notice most of these problems, they want an exact answer. So that means pi is going to be in my answer. I'm not going to plug in a number for pi. So this now really becomes a problem of, I have 435 over 180, the degrees cancel out, times pi. I need to reduce this fraction, and that's going to be my answer. So this is where you might want to use your calculator. Obviously, I can divide top and the bottom by 5. So 435 divided by 5. So here's my calculator. 435 divided by 5 is 87. 180 divided by 5 is 36. Now 87 and 36 do not have a common factor, so that actually should be the answer, and that will check. Oh, see, I misspoke. You know what? I guess you can divide by 3. Good thing I have the answers. So that's an example on the test. If you had a problem like this and this was your answer, you would get partial credit. You would lose some points because you did not reduce it all the way. So 87 divided by 3. So it's really 29. 36 divided by 3 is 12. So this is actually the reduced answer. A little tricky. All right, let's see what we have next. Another conversion. Now this time we're going from radians to degrees. So here's where you would put the answer, you would type it in. So, same idea, 4 pi over 15. My unit fraction, since I'm starting with radians, radians go on the bottom, degrees in the top, 180 degrees in pi radians. Now in this case, the pi's cancel out, so I'm already left with 4 times 180 over 15. Now you could multiply this out and then divide. I'm just going to divide 180 and 15 by 5. So 180 divided by 5. Just to make sure I don't mess up, I won't do it in my head. It's 36 over 3. 36 over 3 is 12. Looks like when it's all said and done, 4 pi over 15 equals 48 degrees. The next one. All right, now we have some problems dealing with the arc length equation. So here's my formula sheet. There are two formulas that we will have to use with it. This is the arc length equation, and this is the area of a sector. So let's look what questions we have, then we can figure out which equation we might have to use. So find the length S of the arc of a circle whose radius 20 miles subtended by the central angle of 1/10 radian. So I think what they're saying, we'll assume we have something like this. They're saying the radius is like 20 miles. And they're saying the angle is 1/10 of a radian. Now you got to remember in this arc length equation, this distance here is the S. So we know R, we know the angle theta, we can plug them in to calculate S. Now be very careful, whenever you try and use this equation, you have to make sure your angle's in radians. This equation only works if the angle's in radians. So in this problem, the angle is in radians, so we can say S should be R, which is 20 miles times 1/10 radian. So 20 times 1/10 is 20 divided by 10. Looks like the answer should be 2 miles, and that is correct. All right, now here, it's interesting, they're going to give you the diagram. Maybe this is really small. I will zoom in a minute on this diagram. Let's look at what they're asking. They're asking us to find the length S, the arc length, and the area A. So we have this sector here. Even there, it's hard to see. Let me raise it up, and I'm going to write it a lot bigger. Very small. So it looks like the angle is 5 pi over 6 in radians, and the radius is 3 feet. So you can see the area shaded in, and you can see the distance, the arc length is S. So they want to know both S, the arc length, and A, the area. So let me zoom back out. I will write those. So this is actually 5 pi over 6 is the angle, and this radius is 3 feet. So this is just a matter of using the two equations. S equals R theta. R is 3 feet. S is 5 pi over 6. Now you notice in this problem, for the answers, type an integer or decimal rounded to 3 decimal places. That tells you they're not looking for an exact answer. You're going to have to get your calculator, and you're actually going to plug in, you're going to hit pi on your calculator. So I go get my calculator. So it's going to be 3 times 5 times pi. Now I have a pi key on my calculator. Hopefully you do too, because you need to type in the actual value for pi, because look at what pi is. It's a whole bunch of digits. So that's 3 times 5 times pi. Then I have to divide all that by 6. So if you can see, it looks like it's 7.8539, They want the answers to 3 decimal places. So this 3 is the 3rd decimal place, but I have to look to the next number to see whether I should leave it at 3 or bump it up. The next number is 9. So to round, this stuff is going to get bumped up. So it's going to be 7.854. And that is correct. So now the area of a sector is 1/2 r squared theta. Once again, make sure your angles in radians. Thankfully, for this problem, our angle is in radians. Now it's 1/2 r squared 3 squared times 5 pi over 6. So once again, I grab my calculator. So in this case, 3 squared is 9. So let's take 9 times 5 times pi. I win the bottom, so I'm going to divide by 2 and then divide by 6. 11.7809. So once again, the 3rd decimal place is 0. What should I do with it? Well, the next number is 9. It gets bumped up. 11.781. And that looks correct. Let's do one more problem. I don't want to do too many problems in a row to make these videos too long. So this is the last problem dealing with arc length. And so this one says a water sprinkler sprays water over a distance of 20 feet while rotating through an angle of 125 degrees. What area of lawn receives water? So here, radius, so it's almost like this is the amount of the yard that gets watered, right? Because the radius is 20 feet, the water is spraying 20 feet, and it rotates back and forth 125 degrees. So like this is the area. This is what we're trying to find. Once again, the area is 1/2 r squared theta. However, look at this angle, 125 degrees. I cannot plug 125 degrees into this equation. I have to first convert 125 degrees into radians, and then I can plug it in. Maybe I'll do it over here, see if I have room. 125 degrees. Degrees on the bottom, radians on the top. 180 degrees, pi radians. Now in this case, because we're not looking for an exact answer, I've used my calculator, but I'm going to write maybe 5 decimal places before I plug it in here. So I'm going to say 125 times pi divided by 180 equals. So I'm going to say 2.18166 just to be safe. 5 decimal places. So that is now the angle in radians. So now I go back over here. The area is 1/2 r squared. The radius is 20, so 20 squared times this angle, 2.18166. Now if I do this, so 20 squared times 2.18166 divided by 2. 3 decimal places, that's actually all we have, 436.332. Actually, I wasn't paying attention. Look at here. Actually, I asked for 2 decimal places. Unfortunately, if you enter this, it's going to count it wrong. So don't be like me. I just assumed these were the same. But it's not. This is 2 decimal places. So 436.33. Okay, we'll stop now and continue on with the next video.